Let's talk about the advantages of optical fiber over the traditional wire, and we will finish C3. Okay, so before we try to look at this page on your textbook, let's take a look of the official study guide first. So what you are expected to know, because if you try to talk about advantages, we can talk about in a very technical way, but what we actually need to know is more qualitative. So here you may see the actual thing that you need to know according to the study guide is simply describing the advantages of optical fiber over the traditional wire, which is the so-called twisted pair and the coaxial cables, okay, which is these two you can see. Okay, this one is the twisted wire, this is the coaxial cable. And so if you try to read through this, then apparently, like I said in the previous video, these are a more previous technology in the past, in maybe 80s, 90s, and what happened is the speed was quite low. I'm not sure if you probably I don't think you I mean this generation will pay attention to the internet speed right now. In the past, when we try to download certain file, maybe it's around 100 something KB per second. That is a normal speed. If you can download as in 1 meg per second, it is already a very good network already. But nowadays, I think it's much faster than this. For example, when you watch YouTube, the speed must be much greater than 1 meg per second. And like I said also last time is when you try to call someone, when the time when it was still something called 56K, that time people, if you try to call someone's home, they will also get disconnected too. So that was some technical difficulty we have in the past, and the quality of life has been improved so much nowadays actually. Not to mention the wireless Wi-Fi. In the past, there's no Wi-Fi at all. I mean, everything has to be connected through wired. And you may find that, hey, Mr. Wong, how come at home you may still find something like this, the cat wire? We call it cat, C-A-T, cat wire. It's nothing to do with the animal cat. The cat here is referring to category. Okay, so there are category 5, category 6, category 7. Apparently this is like each generation it got advanced, and the main difference is it simply got faster every time. Okay, so this one may not be a lot of to do with pure physics, but something to do with maybe some daily life knowledge or technology knowledge. It's very simple stuff, but I think as a new generation learner, I think we need to know more about ourselves in our daily life. So you may find at home, let's say right now, if you try to find, I'm pretty sure everyone nowadays you have something called router, and router basically is trying to get from your building. So let's say at home, you must have a place where it centralize all the wires, and that place will connect the wire to your router, and then the router would emit Wi-Fi to your phone, and you may also connect it with the LAN wire, and this is one kind of LAN wire. Okay, and that may connect it to your desktop directly. And if you really want a more stable speed, let's say if you play online game, then of course you want the LAN cable rather than Wi-Fi, because Wi-Fi, it first of all is slower and also is unstable. So LAN wire of course is still much better. Actually, I personally prefer a lot the LAN wire, unless I have to move around. But yeah, I mean that's the case. So we still use it nowadays when we talk about the router to your computer, to your desktop more precisely. And just because the optical fiber also got its own issue as well, but it's a very tiny issue. Is the disadvantage of optical fiber is actually quite fragile, so you may actually break inside. So it's not easy for you to to work within your home. So the optical fiber we were talking about is more about between the centralized, actually from the service provider company to your building. All right, so your home, and then to the service provider, we call it ISP, Internet Service Provider. If you learn ICT, you know what I'm talking about. And then to your home, and that would be optical fiber also, and that would from your home to, I mean not your home but your building to your home, and that will be optical fiber also. And when you connect it to your router, then here there should be some kind of LAN cable already, or there's another device called modem also. Okay, and we will use that so that it will be much faster. However, if your router is very slow, like it's not a very good model, or your LAN cable, let's say if you're still using Cat5, I think there is a speed limit. I think for, let's say, my home, I'm using, I think, Cat6, because I'm using 500 Mbps, like those plan, you know, when you try to apply like different plan for your internet service. So they are usually nowadays, I think the cheapest one you can get is like 100 or 200 Mbps, and then 500 is like the medial core, and the best so far I think you can get is 1000 Mbps for your bandwidth. So if you get a very terrible old wired, even if you get a really good service, it's still useless, because that will be the bottleneck. Okay, so some daily life knowledge for you. So back to here, how come once again the optical fiber will be much better than the electrical wire? There are a few advantages you may want to recall or understand. Is first of all, optical fiber has a low attenuation. As we learned about, Charles Cow has much improved the performance of optical fiber actually quite a long time ago. For electrical wire, the main problem, or the way, first of all, you have to understand is the way that they transmit signal is by adjusting the voltage. So if you think about the VT graph, so what happens is if they want to send 10110001, then you can imagine the voltage graph will be more like this. Alright, so it's like last time I talked about the Morse code, the on and off. But the thing is, voltage will drop over distance, right? Because the wire itself also get resistant, and so that would take up some voltage. And so you may say, hey, so maybe we can send a larger voltage, then we can kind of overcome this issue. I mean, even if the wire take up some, then it's still fine. That may be true to a certain extent, because but at the same time, the thing is, you don't want to use too high voltage. First of all, that will produce heat, because when you make voltage higher, then at the same time the current will be higher, and that will produce heat, and you don't want that for sure. And that will also take up a lot of energy, which is again not a very sensible way to do it. So using optical fiber is actually a very good way, and also it has a very low attenuation, because the light simply got totally reflected. If you remember, it's 100% reflected, so it's not much lost throughout the whole wire. So the second thing is there is no interference from straight electromagnetic signal. What that means by straight electromagnetic signal is, at home, you may have different electrical appliances, and if you recall in the previous chapter where you learned about electromagnetism, you know that whenever there is current, then there must be B field produced by the current. So the B field actually will affect, from external. For example, when you're boiling water using your electrical kettle, there must be some current, and that current will produce a B field. And if you somehow place your cable close to the kettle or anywhere, then that may affect your signaling in the electrical wire. So that may cause some issue. But of course, in computer science, they have certain way to double check the information, to see whether the signal is 100% correct or not. If not, then they have to resend again. But if you think about it, if they resend again, that already slowed down the speed already. So that's why it would not be as good compared to optical fiber. At the same time, one interesting thing I want to share with you as old business or low bank is that in the past, nowadays I don't think there will be any, but then maybe you can ask your parents if you have not experienced that in the past when you're using this kind of, or actually most kind of speaker, old speaker, computer speaker. And then in the much earlier time, I think around 90s, if you use mobile phone and if you try to make a call or receive the SMS, and there will be some noise which may sound something like this. Not sure if you hear that before, or you can show it to your parents and ask whether they recognize this sound, and I'm pretty sure they would say, hey, that's the sound when you use your phone near your speaker back maybe 10 or even 20 years ago. Right, but nowadays the speaker use a much better way to shield, we call shield the signal, and therefore it won't get affected. And the basic idea of why there's such a sound is because of the interference of the wave, basically. So imagine the mechanism of how speaker work is simply there is a magnetic field change, and that will vibrate the diaphragm inside the speaker, and that electromagnetic signal also affects the way that the current, of course, if you switch on the speaker, then the inside the wire must be ready for emitting some sound, and that signal is going to affect the current flow in it, and that will produce some kind of strange interference sound in it. Okay, so and then eventually that will be produced later on. So definitely it won't be something good for you to hear. It's actually quite annoying. Number 3 is it can get greater capacity for optical fiber, because think about like what we said earlier about electrical wire is either 1 or 0, and think about that. What you can do is you can send 1 or 0 very quickly at a certain rate, right? Like maybe maybe 1 second you can send 1 million of 1 and 0 digit. All right, that would be quite fast already. But then think about for light, right? They can actually do the same. I mean, if you could do this for electrical signal, you should be able to switch on or off the light at the same rate. However, for light, let's not forget, for light, for optical fiber, we could use different frequency. All right, and let's say if it is visible light, you already have a different kind of color, like 7 color, for example. And then you can imagine on the optical fiber, one hand is sending out the signal, but what you can do, you can encode the signal by different color. Somehow, of course, again, there are lots of work to be done by computer science people. And on the other side, so let's say you send out like different color by like on and off, of course, and on the other side, then you can also decode, all right, by different color on and off. And so that will allow a much greater capacity when you're sending it out. Okay. At the same time, the last thing that we may talk about is the security. Again, something called tapping. And if you ever watch some kind of movie about some secret agent, spy, or police or anything, then you may hear of like people tapping someone's phone, like secretly listening to someone's phone, and it could be done by much easier by electrical wire. All right, and once again, that is something to do with the physical nature of electrical wire itself, because they will produce B field. All right, and if you think about, of course, I mean, tapping is not a very simple work you can do easily, but then it is possible that some people, as long as they have your B field pattern somehow detected using a very sensitive, way to sensitive device to detect, they can do back work or reverse engineering to trace and try to find out the electrical signal. So what is exactly your code is basically. So this is how tapping could be done in that case. But if you're talking about talking about optical fiber, then since the light is simply embedded inside the wire, there's no way you can take it out to see unless you, I don't know, physically cut it off maybe. But then that will affect your signaling in that case, since that guy, I mean, surely would know something is wrong in that case. So it's not that easy in that case.